Hi, I am Atanu. In this tutorial video, we learn how to prove the irrational number with the contradiction method. Okay, this is the series of the tutorial of class 9 mathematics chapter 1 number system. So let's start with first question, that is proof root n is a irrational number, means not rational number, if n not a perfect square. If n not a perfect square. Clear? This is the question. We know that if n is perfect square, what will happen? Let's take one example. N is equal to 4, then root n will be what? Root n is equal to perfect square, means it will be 2. So 2 is a what? Rational number. But when it is not the perfect square, then it will be not a rational number, it will be irrational number. Okay, so let's take one example. Let's take one example. If I told you n is equal to 2, then what will happen? Root n is equal to root 2, so is a irrational number. Clear? So how we can prove this statement? So let's check it. So first we assume that suppose root n is a rational number. So we know that if it is rational number, so we can represent as p by q form, and where p and q are the integer. With no common factor. Because means they are the co-prime number. No common factors other than 1, means you can say the co-prime number. And q not equal to 0. This is the condition of what? The rational number, of any rational number. Clear? Then if we multiply it, if we square both sides, then what we will get? Square both sides, n is equal to p square by q square, squaring both sides. Okay, so we can get it from here, that is n q square. Okay, so from this we can say that p square is, since from above, so p square is multiple of n, is a multiple of n, or you can say n is a factor of p. N is a factor of p square. You can say n is a factor of p. Why it is happened? Because see, if I told you some value, for example, that is p square is equal to, if we consider n as for example 3. Okay, for example, let's take one example. The n, suppose the n is 4, so p square is equal to 4q square. So we can say that p square having the factor 2, right? Because 2 is the factor of p square. And then if we square root this number, then we get p is equal to 2q. Okay, from here then p is equal to 2q, then we can say that 2 is a factor of p also. Now you can say that why I consider this 4, because see, if it is not the perfect square, then we cannot do this calculation. P is equal to 2q, it is not possible because we cannot find out the factor. Okay, so if we find out the any integer as a factor, so first we have to consider the n as a perfect square. Okay, then only we can prove that. So here we can say that if n is a factor of the p square, because p square is equal to multiple of n, so n is a factor, then p also then n also the factor of p. If we square root it, we get the n also there. Okay, so n is a factor of p. This is very, very important statement. Very, very important statement. Okay, clear? So we can consider here n so p is equal to we can consider nm. Okay, where is the m is the integer. Okay, nm we can, because p is a multiple of what? Multiple of n, or the n having the factor p, so it is a multiple of n also, correct? Then you just take this statement 1 here, sorry, not this statement, take this one as 1, and then we put the value here. So p square is equal to nm square, n square m square is equal to n q square. So you can say it is 2 and it is 1. So put the value of p, put the value of p in 1. Okay, it's clear. So from here we can simplify, further simplify, n cancel out, n square 1 n cancel out, so we get n m square is equal to q square. So q square is equal to n m square. So from here what conclusion we get? That is q is, so n is a factor of what? Q square. So we can say that n is a factor of q also. So now we get these two statements. This is 2 and this is 3. So from 2 and 3, 2 and 3, we can say that both p and q having the common factor n. But it is contradict, but it is contradict our assumption that p by q having no common factor other than 1, because they are the co-prime. Where we get it? Here. No common factors, that are co-prime number. Clear? P and Q having the no common factors. So whatever our assumption is wrong. So we can say that our assumption is wrong. What was the option? Root n is equal to p by q is wrong. Means root n is not a rational number. Okay, or it is a irrational number. If n is not a perfect square is the answer. Proof. Clear? So with this method, same statement, we can prove that any number, for example, you can replace n with 2 or 3 or 5 or 7, whatever, then we can prove that root 2, root 3, 5, root 7. Only what you have to do, you replace n with this number. The statements are same. You can try it at home. Okay, or irrational number. We can prove that. So no statement will change. The above method are same. You follow this step, but right side this step you no need to write anything, because this is for our understanding only. Correct? This all these three sections no need to cover here. This is only the answer. Okay, with this statement, if you replace with the n, for example, it is 2, it will be root 2. If it's n is equal to 3, root 3, then you just write down wherever it is n is there, you replace with what? 2. So you can prove that. Try it. Okay. So now we prove that root 2, root 3, root 5 and root 7 are the irrational number. So it is clear to us. Then we take one question that for example, if I told you, I give another example, that is 3 root 3. Question number 2, 3 root 3, sorry, it is not like that. 3 is a multiple of root 3. 3 root 3 is a multiple. 3 root 3 is a irrational number. Always remember that the multiple of any irrational number also irrational number. Done. How you can answer this question? This is the question. The answer will be like this. So suppose look at, suppose 3 actually multiple relation, you must remember this. 3 root 3, not inside here. 3 root 3 is a rational number. Okay, so we can say that so we can set let 3 root 3 is equal to a equal to rational number. Clear? So a can be represented as p by q form. Okay. So squaring both sides, we get what? No need to square here actually. The different way you can prove that 3 is equal to a by 3. So left side root 3 here, since a is a, yeah, root 3 is irrational number, and a by 3 is rational number, because a already is a rational number. We just our we assumption is that it is a rational number, so a by 3 also a rational number. Clear? So LHS and RHS contradict here. So LHS and RHS contradict each other. So our assumption is wrong. Assumption of C root 3 is wrong. So C root 3 is a irrational number. Clear? Next we can prove that question number 3. This is actually type of the question. We try to cover at least as per the NCERT syllabus. So let assume another question that prove 2 plus root 3 is a rational number. This is also easy. That is not too much tough. Okay. To prove that. So what will be the answer? So suppose root 2 plus root 3 is a rational number, a, assume it is a. Root 2 plus root 3 is equal to a. Squaring both sides we get q plus 2 root 6 plus 3 is equal to a square. Clear? So what we get, 5 plus 2 root 6 is equal to a square. Clear? 5 plus 2 root 6 is equal to a square. Next, root 6 is equal to a square minus 5 by 2. Since a is rational number, so a square minus 2 is a rational, but root 6 is a irrational number. You already know. LHS and RHS. Each other. Our assumption of root 3 plus root 3 root 2 plus root 3 is a rational number is strong. Proof. Got it? So this proof. This is the end of this video. So we cannot cover the each and every question. Almost it is covered. The concept is, hope it is clear. Thank you for watching this video. Please share, subscribe this channel, and like it also, and press the bell icon so that you get the notification when any new upload will be done. So thank you very much. See you in the next video. Bye.